If atoms are mostly empty space, why can't we walk through walls? It's a question that gets at the very heart of how we understand matter, and the answer lies not in what matter is made of, but in how it behaves. The seemingly paradoxical nature of matter's solidity is best understood through the fundamental principles of electromagnetic repulsion and the Pauli exclusion principle. Electromagnetic repulsion. At the most basic level, all matter is made up of atoms, which in turn are composed of a nucleus of protons and neutrons, surrounded by a cloud of electrons. Electrons carry a negative charge. When you try to push your hand through a wall, the electron clouds of the atoms in your hand come into contact with the electron clouds of the atoms in the wall. Because like charges repel, a powerful electromagnetic force pushes the electrons, and by extension the atoms themselves, apart. This repulsion becomes stronger the closer the atoms get, creating the sensation of a solid, impenetrable barrier. You're not actually touching the wall's nucleus. You're feeling the repulsive force of its electrons. The Pauli exclusion principle. Adding another layer of complexity is the Pauli exclusion principle, a core concept in quantum mechanics. This principle states that no two electrons can occupy the same quantum state simultaneously. A quantum state is defined by an electron's energy level, spin, and orbital shape. When your hand's atoms approach the wall's atoms, the electrons in both can't occupy the same space and energy level. This exclusion creates a massive resistance that we perceive as solidity. Essentially, the electrons refuse to share the same space, making it impossible for the atoms to intermingle and allowing you to pass through the wall. So, while atoms are indeed mostly empty space, the subatomic particles within them are governed by powerful forces that create a barrier, preventing matter from merging. The solidity of matter isn't about its density. It's about the immense energy required to overcome the repulsive forces between atomic electron clouds.